Hello everyone, this is Arif Syarifudin Nur. I would like to present you about time series forecasting using Python. This is the YouTube video of the last time we used RStudio to analyze the time series from J17 data aquifer. So now we also will use the J17 daily high-level historical data of Edward Aquifer. Also, the discharge flow from Spring and Comal Springs, and San Marcos Spring. You can access the data from this website. This is first, we would like to make a forecasting using LSTM using J17 datasets. This is the dataset starting from 1930s until the recent. This is daily data. So first, we need to reshape the data and rescale using the min-max scaler. Here, the dataset I divided into three datasets. First is the training dataset. You can see in the red line, and then validation data for fitting process the LSTM model, and the last is the testing dataset to test the model whether it's good or not. And we use the sequence and the sequence length about 30 days. It's like looking back. So we will make a data set that has 30 days before to predict the next day. So here is how to make the train validation and test data set. First, the left figure is the data sets from the whole data set, and then we like capture the first 30 days into a new like slicing for slice the 30 days, and then make the Y train as the next day. So for the next slicing, we shift the period to the next day until the next 30 days, and make the next slicing. The yellow show the zero slicing, 0.29 means that we collected for the look back of the 29s, and one is for the Y for the result. Also, the next day is the blue one. This is one for the next day, and 29 is the period of the next 30 days, and one for the train. So we keep shifting that to make train validation and test dataset for LSTM models. You can choose whether you want a 30 or 50 to find the best looking back or sequence. So next we made the models, the construction of the models. Here I use the LSTM models with 50 nodes. The input shape is the window, the shape before the 0.29 and 1. And then after that, the dense layer to make the prediction. And then the loss function, I use MSE or mean square error, and using the Adam optimization. For the epoch, I use 100 to find the best models, and with batch size 32. And for the fitting, we use the train and the validation dataset. This is the result of the loss function from 0 to 100 epochs. We can see that the loss decrease in the early epochs and then reach the stable low epochs to 100 epochs. And first, I tried to fit the prediction data. Fit with the training data. The left side is the training data. So the model tried to make the prediction of the training data and compare with the actual data, and it showed that the result really fit the actual data. And then the right graph showed the result of using testing data. As you can see that the predicted and the actual data match with each other. And the RMSE, the root mean square error between the predicted and the actual data is really small, of 0.41. So we can consider that the LSTM model fits really good with the dataset and really well to make the prediction using the testing dataset. I also use the Comal dataset using the same step. So this is the dataset and divided into training, testing, and training, validation, and testing dataset shown as the red, green, and blue graphs. And this is the loss of using 100 epochs. And this is the result, prediction result, with RMSE 2.72. Next, I also use San Marcos dataset. And then this is the training, validation, and testing dataset. Also the loss function using 100 epochs. Using the same model construction and parameters, the result shows that the predicted and actual data fit with each other with a root mean square error about 1.88. Okay, thank you very much. That's all for me. You can find the link of my GitHub in the description. Thank you.